and at the end, based on the timing, I'll demonstrate what we are discussing during this first 1.5 hours. This is the today's plan. It's very simple. If you are having any clarification, please you can ask any cost of it. There's no problem. And again, the insisting, if you already completed your research, you can add one more area in this in your profile. If you are not started, by evening you can start, nothing wrong in it. For electronics, they are doing antennas, with this photonic antenna, for 6G application as well as the 5G application. Second one, nanophotonic devices for IoT and AI based applications, as well as photonic integrated circuits. And for these, many students are there, other participants also there. You can understand this concept. Definitely, you can implement in your project this concept in your project. This is about overview. Let's begin our lecture. Let's begin our session. See, my talk is recent advancements in photonic crystal for photonic integrated circuits. This PIC, photonic integrated circuits, is also like IC, electronic integrated circuits. What's the difference between IC and PIC in the sense? Integrated circuits is electron. The key player is electron, whereas PIC, photonic integrated circuit, where the key player is photon. I mentioned earlier the velocity of electron is 10 to the power of 9. However, the velocity of photon is 10 to the power of 50. The photon velocity is much higher than electronics. So, the scientists and engineers in Silicon Valley in US, they have started to work with photons. Though there are very rich development is come across in nanoelectronics, they are also working parallelly with PIC. This is my plan about this 1.5 lectures. Introduction about the photonic crystal. I wanted to know from your side, how many of you are aware this term called photonic crystals? How many of you are aware? Sir, I know very well earlier. I know this term earlier. How many of you are aware? Please answer. No. Okay, fine. No problem. And second thing, I decided to cover what are the important concepts and principles. Thirdly, optical filters, sensors, what are the losses in photonic crystal, fabrication mechanism, and in futures. This is my outline of the presentation. Let's talk about this slide before the break. See, as I mentioned earlier, there are two pillars, right? Electrons and photons. Electron related with analysis electronics, photon with analysis photonics. The device miniaturization is most important. Okay. In olden days, in first G or 2G mobile phone, you can see the cell phone size is very bigger in size. But now we see here, like 2G and 3G, our cell phone size is coming very small. Nowadays, the ordinary size is there. However, the screen size is bigger. What is the reason behind it to make the screen size is very bigger in the sense? As we are looking many different applications. In the case of 2G, just we can make a call, we can send a SMS. But nowadays, the application is unlimited. Earlier, it is on operator centric. Nowadays, the cell phone communication is user or customer centric. So, as we are using many different applications, we need separate kind of antennas for each and designated applications. In order to provide service to all the applications, there are 4 to 5 different antennas are there inside. If you want to open your cell phone, you can see there are inverted antenna into each corner in order to connect it from base station to your cell phone, which enters cell phone to your base station. and other 3 more antennas are also available based upon the applications. That is the reason to get into a cell phone, display size is much higher in order to position different varieties of antenna. So, initially, we know very well that transistor is very bigger in size. So, vacuum tube and transistor, it is incorporated and it is proposed in the year 1950s. The size of the vacuum tube transistor is much higher. Alternatively, integrated circuit is proposed in the year 1960. That is called IC. In IC means we have already studied in digital electronics also 74002, and other ICs are also available. In fact, in our cell phone also there are many ICs are available. So, in order to complete, in order to perform an application, there are many smaller size of antennas are placed or organized in such a way that to perform, to complete one application that is called integrated circuit. Based upon the number of transistors in an IC, it is subcategorized into small scale SSI, MSI, LSI, very large scale integration and ultra large scale integration. In the case of VLSI, it is proposed in the year 1980s. And there was a hot topic on 2000s, that is actually nanoelectronics or 3-dimensional ICs. Basically, what is the problem actually in the sense? We are seeing that 63 nanometer technology, 47 nanometer technology, 60 nanometer technology, and 11 nanometer technology. Here, the nanometer represents the distance between your drain and source. That is actually the nanometer technology. So, in the case of 10 nanometer, 11 nanometer slash 10 nanometer technology, what happened is, as the distance between source and drain is very limited, if the power dissipation and losses keep on increasing once the device dimension is getting reduced. That's the problem that they have faced in the year 2012. Subsequently they have stopped their work for 2 years, some couple of months in order to rectify the issue, and they have started parallelly 3-dimensional ICs by common shaping mechanics. What is the present development? Now, Intel and Samsung, they have started to use 6 nanometer technology for the upcoming 5G and 6G cell phones. And they are also predicted the second version of 6G will be with 3 nanometer technology and 2 nanometer technology. Just think about it. The distance between source and drain is 2 nanometer, which gives better performance, which in turn the amount of power that is required to operate, to enable the device is very, very low. So, smaller amount of power is highly sufficient in order to operate the device. That is the reason behind it. You can see in olden days, your cell phone charger, it is mentioned that initially plus or minus 24 voltage. Nowadays, you can see it is plus 3.4 voltage and 2.8 voltage and 2.4 voltage. The thing is, they have incorporated many number of transistors with lower level of nanometer technology where it requires minimum amount of power in order to operate. That is the question is coming. So what is the future? What may be in the case of 2030 or 2040? Whether 1 nanometer technology, 0.1 nanometer technology, 0.001 nanometer technology will come or not? That is the question is coming. But we can't predict. And also one more question is asked. If 0.01 nanometer technology came into the picture for all applications, what is the processing power? Will it be required any power to operate the device? or the device will automatically get the power from the internal sources. Still, the discussion is going on. So hopefully we may expect in the year 2030 what about 0.1 nanometer technology. These are all the development in the electronics present. I am talking about what happened last week in the case of nanoelectronics. We are not enjoying 2 nanometer, 3 nanometer technology. However, already it is proposed 2 nanometer and 3 nanometer technology. Hopefully, we know very well that Moore's law. Moore proposed a law in the year 1965 is mentioning that every 18 months number of transistors in a chip will be doubled. And by observing the technological development for device miniaturization in electronics, he revoked his statement in the year April 2012, so the Moore's law will not be applicable for. That's the statement. So what happened in the sense, the development of transistor, the nanometer technology improvement is predominantly increased. It is unpredictable. Hence, the Moore's law is revoked. That is the development of electronics. Similarly, the photonics also having equal development. See, in the case of photonics, 1960s, all the applications, all the components, all the devices, both active as well as passive devices, is fabricated in discrete in nature. All the component is fabricated in discrete in nature and is connected to them. And we came to know that by connecting one device to another, increases the losses, that insertion losses. Because of insertion losses, the overall performance gets deteriorated. In order to overcome the performance deterioration, they have decided to implement what's happened in the electronic IC. Similarly, they have decided to have that PIC. For that, first developed is planar lightweight circuit. So, in a single slab, they have started to fabricate 2 or 3 devices. In a single slab, they have started to fabricate 2 or 3 devices. That is about planar lightweight circuits. The dimension is the range of centimeter to millimeter, the device dimension. So you just see here millimeter size of optical devices. And in 1980s, optical MEMS is proposed. Still now, many medical applications, optical MEMS based components are used. And in fact, many industries for controlling applications, they have utilized optical MEMS based sensors. In fact, for IoT applications also, they are utilizing optical MEMS. Why? Because it gives a perfect result than the electronic based sensors. The thing is one more thing. What is the problem in the case of optical MEMS? See, the optical MEMS will be operated by having the mirror as well as many movable components inside the device. As the optical MEMS based devices having many movable and many mirror based components, it introduces many scattering losses and reflection of light based problems. So hence, while going to minimize the device below 5 micrometer, by the time the optical MEMS have been started the problem. So in order to overcome the issue, the new term called photonic crystals is proposed for photonic integrated circuits. Photonic integrated circuits similar to electronic integrated circuits, where the photon is going to play very important role for propagation, amplification, emission, controlling and containment of light for any applications. What the electronic IC is doing, the same function will be done by using photonic crystal based ICs. So that is about photonic integrated circuit. This is about the development of electronics as well as the photonics. Today we are going to talk only about these photonic crystals. We are going to talk only about the photonic crystals. And this is the comparison we have discussed. See, there is mechanical relay. In olden days, it is doubled every 7.5 years. By the time the industry 1.0 is in position. Nowadays, we are at industry 4.0 application. See, after that, this is about Moore's area. 1965, doubled 18 months and doubled 1 year, doubled every few months, and no more. It is the year 2012. As I stated earlier, at present the research is going on both Intel as well as Samsung in 3 nanometer and 2 nanometer technology. If anybody is ready to work at Intel or Samsung, please you can key, if you are very keen about 3 and 2 nanometer technology, there is the provision, there is the opportunity you can land either Samsung research lab or Intel research lab. And this is about the comparison. So electronic IC, the development is enormous. However, photonic IC, PIC is not developed much while comparing with the electronics. However, the research is progressing both to increase number of devices, number of transistors in the chip, both electronics as well as the photonics. This is about the comparison of electronics and photonics. You see here that the speed is about 10 to the power of 9 and the size is reached 2 to 3 nanometer, and photonics it's about 10 to the power of 50. The device dimension is touched about 1 micrometer. Just to see, the device is 1 micrometer. Okay, and it is the future as discussed. Basically, when comparing with one generation to another generation, one technology to another technology, as we are the ICT engineer, information and communication engineer, we have to think about what is the size of the device. And second one, what is the operating speed of the device. And third one, the cumulative performance of the device. We have to primarily account all the 3 parameters. Based on our requirement, we can make some optimization. Okay, speed is predominantly good, size is okay, bit higher, performance is also good. Okay, we can consider this size. Anything, both electronics as well as photonics. These 3 factors, one electronics engineer must consider in their applications, whether the performance, speed, size are better than the previous one, or anything is better, or at least one is better. This is the comparison of electronics and photonics. So let's talk about the device miniaturization technology for photonic crystals, optical communication. As I stated earlier, planar light circuit is the PLC. The overall device dimension is smaller, that is in terms of millimeter alone. But the optical lens, it gives the device dimension in the term in the range of millimeter to micrometer. Still, we are working with optical lens-based devices. But the problem, as I stated earlier, below 5 micrometer, it increases the scattering and reflection losses. Also, it is operated with mirror. The aging problem of optical devices is started. The thing is, day one the performance is good. But day 100, we may not expect the same performance. What's the performance that we attained day 1? So in order to overcome that photonic crystal is proposed. So with this, we'll have a small break. After the break, we'll discuss in detail about the photonic crystals. Yes. So meanwhile, please let me know that if you are having any clarifications, please speed up or please slow down. Just I can make accordingly. My presence here is I wanted to share my expertise, my experience in this area as well as research applications. Okay, thank you.